So for today's lesson, we're going to talk about rates, ratios, and proportions. Now, when we're talking about rates and ratios and proportions, a lot of people are going to talk or think about a lot of different things. We talk about ratio of students, boys to girls in a classroom, or the ratio of apples to oranges in a bowl, or things like that. So we're just going to talk a little bit about what ratios are and what rates and proportions are. So a ratio is just a comparison of two quantities using division. So when we talk about ratios, again, we talk about boys to girls. So it might be something like 2 boys to every 3 girls in a classroom. So that's one way you could write it. You could also write 2 to 3. So these are 2 different ways of writing it. You could also write 2 over 3. So these are just 2 different ways of writing ratios. Now, if we talk about something, a rate. A rate is just a ratio that compares quantities measured in different units. So when we talk about, driving, for instance, would be a prime example. We drive at 60 miles per hour, okay? Or, 5 feet per 30 seconds, something like that. So these are rates, okay? Rates are just quantities when you guys think about those. Now, if we talk about a unit rate, which is unit rate is a rate whose denominator is 1. And then a unit price is the cost per unit. So, for example, we go back to, the miles per hour. So, 60 miles per hour, $2.50 per box of crackers. These would be a unit rate and a unit price. So let's take a look at an example here. Which is a better buy? 5 cans of tuna for $4.95 or 6 cans for $5.75? So we're trying to find a unit rate here. So we're going to take the total cost and we're going to put over the number that we have. So for instance, if you're here, we have the total cost is $4.95 for tuna at 5 cans, or corn, or 6 cans for $5.75. So then you would put $6.75 over 6. So $5.75. So if we take these numbers here and we divide them, so when we divide them, we get for $4.95 divided by 5, we get 99 cents per can. And for the other one, we get 96 cents per can. So we can tell that the 6 cans for $5.75 is a much better buy. So that's how we're going to try to find unit rates. So we'll look at example 2 here. A bus driver drives at 30 miles per hour. What is the rate of the bus in miles per minute? So we're just going to put, he's driving 30 miles per 1 hour. And we know that 1 hour is equal to 60 minutes. So this is how we're going to write this out. We're going to multiply these two. Now when we multiply, you can see we can actually reduce these. The 30 and the 60 are going to cross out. So 30 will go into 30 one time, and 30 goes into 60 twice. So when we multiply it out, it's 1 over 2. So what happens is if the driver drives 1 mile, it takes him 2 minutes. Okay, so he's driving a half mile for each minute is how you would be the answer to that problem. Now, when we talk about, anytime we talk about rates and ratios, we also talk about proportions. And a proportion is an equation that shows 2 ratios are equal. So we're going to use the cross products property is what we're going to use. So if we kind of did this on the last problem, that if we took something like A over B is equal to C over D, then what we're doing is we're going to cross multiply. So in this case, AD is going to be equal to BC. So we're going to use cross multiplication in order to solve a problem. So for instance, if we took x over 15 is equal to 2 over 3, we're going to cross multiply these two and solve for x. So we multiply 15 times 2 and we get 30 equals 3 times x is 3x. We'll take that, now we'll divide by 3, and we get x equals 10. is our final answer. So all we did there was just cross multiply to solve our problem. If we want to try another one, you can have x minus 1 over 12 equals 1 over 6. So again, we're going to cross multiply. So 12 times 1 is 12 equals, now when we do this here, remember we're basically going to put the x minus 1 in parentheses and we're going to do the distributive property. So we'd get 6x minus 6. So then what we're going to do is we would add 6 to both sides and get 18 equals 6x. We'll divide by 6 and get x equals 3 for our final answer. So let's take a look at our last example. The ratio of boys to girls in an algebra class is 3:2. The class has 25 students in all. How many boys and how many girls are in the class? So what we're going to do is we're just going to simply solve for one of the two. We're either going to find the number of boys or we're going to find the number of girls. Let's go ahead and look for the number of boys. So we have the rate of boys to girls. So we know there are 3 boys in the class for every 2 girls. Okay, so for that we have a total of 5 kids. A total of 5. 3 plus 2 is 5. So we have 3 over 5. So for every 3 boys, there's 2 girls. So what we're going to do then is we're trying to figure out how many total boys we have in the class. So our total is going to be at the bottom here. We have 25 students in the class, and we're looking for the number of boys total in the class. And here we're just going to cross multiply and solve. So 25 times 3 is 75 equals 5b. Then we're just going to divide by 5 and get an answer of b equals 15. So now that we have that, we could technically solve this for girls. You could substitute, instead of having the 3, you could have a 2 and solve it from there if you really wanted to, and you'd have get a different answer. Or since we already know how many kids are total in the class, we know there's 25 total kids in the class minus the number of boys is going to give us our girls. So 25 minus 15 is 10. And that tells us the number of girls in the class. So if we have 15 boys and 10 girls total in the class.